Hi. Welcome back. In today's class, we will be learning Introduction to Machine Learning for Data Analysis. Machine learning, ML, is an essential field of data science that allows computers to learn from data and make predictions or decisions without being explicitly programmed. In this class, we will introduce the fundamental concepts of machine learning, focusing on its application for data analysts. You'll learn the difference between machine learning and traditional analysis, the two main types of machine learning, supervised and unsupervised, how to build a simple predictive model using Scikit-learn, and how to evaluate and interpret machine learning models. By the end of this class, you will be able to understand the difference between machine learning and traditional data analysis. Learn about supervised and unsupervised learning. Build a simple predictive model using Scikit-learn. Understand the key metrics for model evaluation and how to interpret the results. Understanding machine learning versus traditional analysis. Traditional data analysis. In traditional data analysis, the primary task is to extract insights from historical data using statistical methods. This includes tasks like data cleaning, preparing the data by handling missing values, removing duplicates, and formatting. Exploratory data analysis, EDA, visualizing the data to find patterns, trends, and correlations. Statistical analysis, using measures like mean, median, standard deviation, etc., to understand the central tendency and spread of data. Predictive analysis, using statistical models to forecast future trends. Traditional analysis requires predefined rules for interpreting data and often relies on manual input from analysts, making it time-consuming and potentially subjective. Machine learning. Machine learning, on the other hand, automates the process of discovering patterns and making predictions from data. Rather than using explicit instructions, the machine learns patterns from the data itself. This approach allows for dynamic models that improve over time with more data. The major difference is that machine learning models do not rely on manually written rules. Instead, they adjust themselves based on the data they are trained on. As the model is exposed to more data, it refines its predictions and decision-making ability. Supervised versus unsupervised learning. Machine learning algorithms are generally divided into two main types based on how they learn from data: supervised learning and unsupervised learning. Supervised learning. In supervised learning, the algorithm is trained on labeled data, meaning the output or result is known in advance. The goal is to learn a mapping from inputs to known outputs so that when new data is presented, the model can predict the correct output. Key components. Labeled data. Each input in the dataset is associated with a known label output. Training. The model learns from the training data to identify relationships between inputs and outputs. Prediction. Once trained, the model is tested with unseen data to predict outcomes. Common algorithms. Linear regression, for predicting continuous values. Logistic regression, for binary classification tasks. Decision trees, used for classification and regression. Random forests, a collection of decision trees to improve prediction accuracy. Support vector machines, SVM, used for classification tasks. K-nearest neighbors, KNN, used for classification and regression. Example. A supervised learning algorithm could be trained on a dataset of housing prices, input features like square footage, number of bedrooms, and the corresponding prices, output label. After training, the model can predict the price of a new house based on the input features. Unsupervised learning. In unsupervised learning, the algorithm works with unlabeled data, meaning the outputs are unknown. The model's goal is to discover hidden structures or patterns in the data. Unsupervised learning is often used for data exploration and grouping similar data points together. Key components. Unlabeled data. The data does not have predefined labels or outcomes. Clustering. The model groups data points based on similarity. Dimensionality reduction. The model reduces the number of features while retaining the essential information. Common algorithms. K-means clustering, groups data points into clusters based on similarity. Hierarchical clustering, creates a tree of clusters. Principal component analysis, PCA reduces the dimensionality of data to identify the most important features. Autoencoders, used for unsupervised learning, especially for anomaly detection and data compression. Example: an unsupervised learning algorithm could analyze customer data to segment customers into groups, clusters, based on purchasing behavior, without needing any pre-labeled categories. Building a simple predictive model with Scikit-learn. Scikit-learn is a powerful Python library for machine learning. It provides simple and efficient tools for data mining and data analysis. In this section, we'll learn how to build a basic machine learning model using Scikit-learn. Steps to build a model. Import libraries. Import necessary libraries like Scikit-learn, Pandas, and NumPy. Import Pandas as PD. From scikit-learn.model_selection import train_test_split. From scikit-learn.linear_model import linear regression. From scikit-learn.metrics import mean_squared_error. Load and prepare data. Load the dataset, for example, a CSV file, and split it into features, X, and target, Y. Data equals PD read_CSV, dataset.csv. X equals data, feature 1, feature 2, hashtag independent variables. Y equals data, target, hashtag dependent variable. Split data, split the data into training and test sets. X_train, X_test, Y_train, Y_test equals train_test_split, X, Y, test_size equals 0.2, random_state equals 42. Create and train model, instantiate the model, e.g., linear regression, and train it on the training data. Model equals linear regression. Model.fit, X_train, Y_train. Make predictions, use the model to predict outcomes on the test data. Predictions equals model.predict, X_test. Evaluate the model, evaluate the model's performance using metrics like mean squared error, MSE. MSE equals mean_squared_error, Y_test, predictions. Print, F means squared error, MSE. Model evaluation and interpretation. Once a model has been built, it's crucial to evaluate its performance to understand how well it generalizes to new, unseen data. Key evaluation metrics. Accuracy, the percentage of correct predictions, used mainly for classification problems. Precision, the percentage of positive predictions that are correct, important in cases where false positives are costly. Recall, sensitivity, the percentage of actual positive instances correctly identified by the model. F1 score, a balance between precision and recall, used when you need to consider both false positives and false negatives. Mean squared error, MSE, a measure of how close predictions are to actual values, typically used for regression tasks. Conclusion. In this class, we introduced the key concepts of machine learning and how they differ from traditional data analysis. We covered the difference between supervised and unsupervised learning, how to build a predictive model using Scikit-learn, the importance of model evaluation and the key metrics used to interpret a model's performance. Machine learning enables data analysts to go beyond simple analysis by leveraging algorithms to discover patterns and make predictions. Understanding how to build and evaluate models is a crucial skill for any data analyst aiming to apply machine learning to real-world problems. Thank you for listening. See you in the next class.